Welcome to the second part of Unit 5, the Pythagorean Theorem. Today we're going to be dealing with what do you do when you run into some issues with radicals and decimals as you work your way through. Now, just to let you see, this is the sheet we're actually working on, even though we are going to start on the other side. So let's go ahead and flip over. Okay, help with breaking down radicals, because a lot of times answers on standardized testing are going to be in a format where they're in radical form. They're not going to be in this decimal, and you don't want to take the time to try and figure all this out. So, understanding your perfect squares up to 10 will help. Now, I'll be honest, 1 squared isn't going to help much. But the rest of these, being able to recognize what 6 squared or 7 squared is off the top of your head, comes in very handy when you're trying to break down a radical, like we're going to try to do here in a moment. Now, for some of you that are going to have issues if we get done with this, you still can go back. I'm going to show you an alternate way, but kind of try to stay with me and give yourself a chance on this. So when we go to break down a radical that doesn't match your answer, let's say you get the square root of 45, you don't see the square root of 45 as an answer. Okay, we're looking for two factors, two numbers that multiplied equal 45, but one of them has to be in our magic list up here above. Okay, the numbers we came up with, the 4, the 9, the 16, and so forth. And we always want to try to find the largest one. So for instance here with 45, 9 times 5 is 45. 9's in the list. Okay, let's give 9 a little more special attention here with a color. We're going to take the square root of each of those. 9, because it's perfect, gets out of radical jail on good behavior. It becomes 3. New identity, no jail. 5 is still acting irrationally. Little math joke there. It has to stay in radical jail. This is the simplified version of that radical. Okay, that would be the answer you would see on a standardized test, or that some of you that are in Algebra 2 are going to be dealing with, or maybe even Algebra 1, with trying to work this out that way. But as we work along, now this time we're going to kind of split this one off a little. 72, a lot of times students will say, okay, 9 and 8, which, you know, legitimately works because 9 is a perfect square. It's from our list. And they take the square roots and they're sitting there. And they're like, okay, it's 3 square root of 8, but they still don't have the answer. It doesn't match up with anything. So they're like, well, what did I do wrong? I did all the right steps. So let's take a look at another way to do 72. Notice how I said you need to find the largest factor. 36 will go evenly into 72. And you always can try just dividing these numbers by your calculator. So 36 gets the attention this time. Square root of 36 is 6. Square root of 2. That's your right answer. But can I still get to the right answer here? The answer is yes. Well, how would I do that? 8 can be broken down. Oh yeah, because 4 goes in there. So I'd have 4 and 2. Square root of 4 again. Perfect. Perfect squares get out of radical jail. Square root of 2. And then that 3 that was up here in front before is still involved. 3 times 2 is 6, and I get the same answer. But notice all the extra work I'm having to do. That's why it's best to get the biggest one out the first time. Okay, we're going to take a look at just a couple more. And again, if you're not sure sometime on one of these, you're like, ooh, 128, that's a big number to deal with. Just try dividing these in. If you know these, it's not that hard to try dividing them in on a calculator or in your head. Get the biggest one, get to the right answer. Okay, one last one with 48. Now think about this for a minute. I'm going to pause for a moment because there's lots of numbers that will go into 48. Think of the biggest one that's in our perfect square list up above that goes into 48. Which one is it? Is it 4? 4 goes in. And there's a better one, and it's 16. Square root of 16 is 4. Square root of 3. Whoops, got to move that up a little bit. So now that you have a little background with this, let's see how this could actually apply to some ACT level type questions. Let's flip over. Sorry if I made some of you dizzy there for a second. So now we come up to example 1, and it's going to work its way all the way down this side of the page. So you're like, ooh, Pythagorean theorem. There's A and B. which means there's our legs, and we're looking for the hypotenuse. So I'm like, okay, legs squared. Notice I'm in parentheses, just a good idea. Plus legs squared equals hypotenuse squared. So I start to take a peek and I go, well, squared and square root are arch enemies. So we're just left with what's underneath it. They're inverses, squared and square root. So I look and I'm like, okay, 28 is c squared, but I don't want c squared, I want c. So I get c as the square root of 28. However, if I take a look down that column towards the bottom where all the solutions are, down here, I notice the square root of 28 isn't down here anywhere. Well, heck, what's going on with that? Well, if we take what we just did and break it up, what goes into 28 that's on your list? If you need to take a minute and flip the paper over and look at it that way, you can. You're looking like, well, 4 does. I'm not sure if that's the biggest one, but it ends up being in this case. 2 square root of 7, and I'd have the answer. But again, some of you are saying, but I'm not good with my multiplication facts. Doing this is going to take so long. Here's your other option. When you get to the square root of 28, okay, you can go to your calculator and hit the square root, and the square root of 28 is about 5.29. Now, how's that going to help me? Because I don't see 5.29. You can start punching in answers until you find one that matches. Now, since most of the time answers are in order from the least value to the greatest, I usually tell people to try the one, towards the middle where C is, so you could figure it out. Now, in this case, we know what the answer is going to be. So if you type 2 times the square root of 7 into your calculator, you see it also comes up as 5.29. So there is a way to get to the answer if you're not good at breaking down the radicals. But I'd say try it a little bit because it's going to save you some time in the long run. Okay. So let's come back up here. We've got a couple more examples to look at. Example 2, leg, hypotenuse. So since we have the hypotenuse this time, again, it's hypotenuse squared minus leg squared equals our missing leg squared. And again, squared and square root. If there's just a square root there, again, you're just going to take the value that's underneath it. And you knew what was going to happen here. You're like, oh man, you can't even give us one that just comes out nice. Not today. So I start to look at the answers, and I'm like, okay, I'm going to try this breakdown thing. What times what gets us to 45? 9 and 5. 9's in our list. And if you got to keep referencing the list, you do for right now. Okay, 3 square root of 5. Be careful. It's the perfect number that gets out of radical jail because they can try to trick you by just switching the values around, and it does make a difference, so be careful. Last twist we can throw at you. You're like, well, what's so tricky about this? Here's the hypotenuse, here's my legs. So I take this squared plus this squared equals x squared. Here's the catch. Where it's just the square root of 22, you still can do this. There's your 22. Okay, that's fine. The first term, though, that squared goes to the 3 and to the square root of 2. When that 2 goes to the 3, okay, that's 3 squared. That's 9, because there's no radical over it. It still is going to cancel when it comes to here. So you actually have to square the number that isn't under the radical. Then you can work it out. And again, it's one we have to break down. And you'll notice with the answers, if I forget to break down my 4, that answer's there. Weren't mean with 10 square root of 2 this time. But again, be cautious, take your time, but work through these. Get used to it a little. I'm sure you'll find some good success with it.